In this chapter, we dive in steel connections in mass timber. Steel and timber, two materials that, when combined, push architectural boundaries. Let's dive into the details. In wood joinery, there is a whole range of connections, one stronger than the other. In the graph, you can see a comparison in strength of wood, steel, and glued connections. A fastener is a hardware device that mechanically joins or affixes two or more objects together. In the context of timber and steel architecture, fasteners secure these materials in a stable configuration, each offering unique advantages for specific applications. First up, we have screws, ideal for both timber to timber and timber to metal joints. Specialized versions offer anti-split tips and corrosion resistance. Need something stronger? Bolts and nuts are best suited for high-stress applications. They offer higher tensile strength than screws but require pre-drilled holes. Now, if you're looking at temporary or less critical connections, don't overlook nails and staples. Their shear strength is limited compared to screws and bolts, but they are quick and easy to install. When aesthetics matter, concealed fastener systems offer strong joints without visible hardware. Beams and joist hangers act like the backbone of your structure, channeling loads into your vertical supports. Finally, we have anchors, essential when you need to join timber to other materials like concrete or steel. Depending on your needs, you can opt for mechanical anchors or for quick installation, or adhesives anchors for a more permanent solution. And remember, these are just some of the most common fastening systems. The world of connectors and other structural elements is broad and specialized to meet varying project needs. Let's dig a bit deeper into what makes steel timber connections both appealing and challenging. On the one hand, we have a marriage of materials that can offer structural advantages, such as enhancing timber's natural compressive strength with steel's tensile capabilities. This allows us to create incredibly robust and resilient structures capable of withstanding immense forces. Steel connectors also offer more flexibility. They open up possibilities for more intricate and spacious architectural forms. Plus, they come with the added benefit of being durable and efficient to install, saving time and possibly costs in the long run. But there are some negatives to consider as well. For instance, the upfront cost of steel connectors can be much higher than traditional wood-only connections. And if you are aiming for a natural all-timber look, steel elements could pose an aesthetic challenge. And let's not forget about thermal bridging. Steel, being a good conductor, can compromise your building's thermal performance if not carefully designed. It can create pathways that allow heat to move through the building's envelope, affecting its insulation and energy efficiency. So as you can see, like anything in architecture and engineering, it's about understanding and striking a balance. Take a look at this diagram, which visually distinguishes between three types of joints. The first is simple stacking, which involves no steel elements and has a limited load-bearing capacity. It's the most basic, but sometimes that's all you need. The second is the simple steel connection. This utilizes basic steel fasteners, offering a medium range of load-bearing capacity. It's suitable for various applications, but not for heavy-duty structural needs. And finally, we have the advanced steel connectors designed for heavy load-bearing requirements. They use specialized steel hardware to maximize strength and durability. These joint types represent a range of choices, each with its own pros and cons. Keep them in mind as we delve into the specifics of steel timber connections. Rotoblas and other manufacturers take us into the future of steel timber connections, from fastening systems to complex structural elements like the spider and pillar connectors. Take a look at this detailed image. See the green arrows? They indicate how the spider connector transmits vertical load from one column to another without compressing the CLT floor. Now, notice the blue arrows. They show how the floor isn't just sitting, it's suspended. This is achieved through fully treated screws working in traction. And what about shear forces? Spider tackles this too, by reinforcing the CLT layers with inclined screws. As for flexibility, Spider allows for a large 7 meter by 7 meter grid, perfect for open floor plans. Next, we have the pillar connector, similar to Spider. Pillar also uses a central steel plate for vertical load transmission, as shown by the green arrows. But unlike Spider, the blue arrows indicate that the floor simply rests at the column head, transmitting vertical forces through compression. For those wondering about grid sizes, pillar is more constrained, working well for a 7 meter by 3 meter 50 grid. In the real world, the pillar connector has proven its worth. Take for instance the Brock Commons project by Acton Austria Architects. Here, pillar connectors were essentially to provide the load transmissions for the 18-floor building. As we delve deeper into the world of steel timber connections, let's consider a monumental example. The Mjøstarnet in Norway, designed by Foll Arkitekter, Mulven Limtree faced strict building requirements. Due to the particular characteristics of wood, steel components were essential for meeting these standards. Nordic Steel supplied specialized slot fittings and plates to achieve the necessary stability and safety. Notably, the slot plates have a tight tolerance requirement of 0.5 millimeters, exemplifying precision in construction. That's as narrow as the tip of your ballpoint pen. Innovation and future-forward thinking are shaping the landscape of timber connections. But the essence remains the same: the right connection for the right application.